Alright guys, so I am going to finish off our notes. Let's look at the normal distribution. I'm hoping to get through this quickly for you. Let's start off with just remembering the empirical rule. Remember, one standard deviation away would give you a z-value of either +1 or -1, and so on. Here, I am going to go through using the calculator. In class, we talked about how to calculate a physical z-score. And remember, we went through what a z-score would look like. So this is the last problem we looked at. We were looking at IQs with a mean of 100, a standard deviation of 15. And so we were looking at different normal distribution diagrams that I do want you to do. I want you to sketch so that we can physically see what area you are finding. So things that you want to remember, the area underneath the whole entire bell curve would be 1. And the probability matches the area. So because the values, the x values can be any values, what we do is we normalize them, and how we normalize them is by using that z-score. So even though x is 140, there's also a z-score that goes along with this, which is 8/3. So 8/3 tells me we are about 2.66667 standard deviations away from the mean. So remember, we know our empirical data, or our empirical values. We know 2 standard deviations away would be 95% between those two. So I really want to be careful with this. So let's look at just one more type that you would get, maybe looking at the probability that your x is between, let's say, maybe 95 to 121, something like that. So making sure you draw your curve. We know where our mean is. Our mean is 100, and then 121 would be somewhere to the right, and then 95 would be a little bit to the left. So these are really my x values that I'm showing you here. And then what you need to do is, using these x values, you have to turn them into z-scores. Okay? So that is one skill you should have. Remember, z-scores are, oopsie, wrong way, x minus mean. So that just is the distance away from the mean, and then we turn that into how many standard deviations away we are. All right, so let's go back to using the calculator. We used to do z-tables, which what you did was you calculated your z-value, and then from the z-value there was this table that would give you all these different areas. And now they have, I believe, done away with that. I'll double check that, but I'm pretty sure we're at a point now where we get to just use the calculator, which is really nice. So, second vars, you're going to do a minimum, a maximum, your mean, and then your standard deviation. So I'm going to give you a problem to do. IQ, which has a mean of 100 and a standard deviation of 15. And we're going to do one that we know. I want to find the probability that your IQ is less than 130. And 130 is exactly 2 standard deviations away. So first thing I'm going to do, I'm just going to draw the picture real quick. So there's your mean of 100. 130 is somewhere up here. I want to know less than. Okay. Reviewing our z-scores, let's actually find our z-score. Our z-score for 130 would be 130 minus the mean, which is 100, divided by a standard deviation of 15. So we know that the z-score is exactly 2 because 130 is 30 above 100, which are 2 15s above 100. All right, so we have a z-score because that's one of the questions you could get. The next question is, what is the probability? So in answering this question, now that you have a z-score, you would then go to a table and look at these values. And we're not going to use the table anymore. We're going to use the calculator. So CDF. There's one that's PDF. Please don't use that one. We use the CDF, which is a cumulative probability. So first number that we're going to use is a minimum. Now, the minimum is somewhere over here, which we all know that this continues on and on and on, but that the area does become negligible. So we pick a number that we know is at least, let's say, 8 standard deviations away. In this case, I could easily pick 0. 0 is far away enough, so 0 would be my minimum. My maximum would be 130. My mean would be 100. And my standard deviation would be 15. So, using the calculator here, second bars, number 2 is the cumulative, lower value 0, upper value 130, mean of 100, standard deviation of 15, and for those of you that have the other calculators, you would have this right here, normal CDF of 0, 130, 100, and then 15. Press enter. And that value that you're getting, 9.997. What that says is the area underneath the normal distribution curve up to this x value of 130, which is the same as the area up to the z value of 2, would be 0.997. Now, 2 standard deviations away, you guys know the empirical rule of 95, but remember, we're now including that other part of the tail, which is why the value is not 95. Okay? So, moving forward, so calculating a probability using a z-score. So first of all, you're going to take your x value, and you're going to use the formula z is equal to x minus mu all over standard deviation. I'm actually going to pull up a z table so you do see it, because you'll hear people talk about the z table, and if you take AP Statistics or a statistics class in college, you'll probably see your z table. So here's what a z-table looks like. It's actually a little bit more complicated than using the calculator because a z-table will give you pretty much the z-score, and then you have to use the approximate z-score to 2 decimal places to find the area. So looking back at our problem prior, I know I'm scrolling a bit, the last one we did, we had a z-score of 2. So 2.00 would be the approximate value. I'm going to go down to, sorry, I had to get a better table. So right here, if you're looking, I just Googled a z-table for you. So 2.0, and this would be 0.00. Here is the value that the z-table gives you. And so this is always giving you the value of the area less than that z-score. Okay, less than or equal to that z-score. So looking at the example we did, it gives me exactly what I wanted here. Okay, so that's what the z-table looks like. It takes your z-score, then transfers it over, does the calculation to give you the area to the left of that z-score. So, let's see. Here, calculating the probability using a z-score. I believe you guys have a z-table in your books, and I would like you to do a few of them using a z-table, please. I am under the impression that you will be doing mostly calculator problems for these, but I would still like you to try it just in case, because this is a new exam. You never know if I got false information at training. So to start off, we are going to find our z-value. Second thing we're going to do is sketch and shade area for probability. And then 3, we're going to either use a z-table or calculator to find probability. And in the next example, I'll do them by z-table. So remember, using the calculator, normal, C, DF, cumulative, minimum, maximum, mu, and then standard deviation. Either of these two values, whichever one you're using, that you're using the tail. Remember the tail, you want to be, pick a random, 5 standard deviations away, at least. Which is why I used 0. I could have even used the negative value. I understand that there's no negative IQs, but given that the data turns into just a number line of values, I could have used negative 100. It'll give me the same exact probability. All right, so looking at this example here. So here is my mu. Here's my standard deviation. What's the probability that he or she is younger than 26? So first thing I want to do, probability that he or she is younger than 26. So as I said before, start off with this guy. You are putting 24.5 right here. And then in blue, I will put my 26, which is here. Okay, so first thing I'm going to do this one as a non-calculator problem. I'm going to do my z-score, which is my x value minus my mean divided by my standard deviation, which is 0.6. So that should make sense if you really understand your z-scores. If my standard deviation is 2.5, which is listed right here, if I was a full standard deviation away, I would be at 27. So 2.5, 24.5 plus 2.5 would get me to 27, and 26 is less, therefore my z-score is going to be less than 1. So there's my z-score. From my z-score, I'm going to pull up a table, which I think I have, and the value I'm going to look for is a z of, let's see, right here, 0.6, so 0.7257. Let's see. So the probability is equal to 0.7257. And then just to confirm it, I'm going to use the calculator. Second, bars. CDF is number 2. So looking at my graph right here, I'm going to pick a number that is many standard deviations away. So standard deviation was 2.5. I could easily pick 0 again. I'm going to a maximum of 26. So these are x values that I'm using. My mean was 24.5. And then my standard deviation was 2.5. And I know you're thinking, why are we using the table at all? That is my fear of what if they told me wrong information and you still have to use the table. So exact same value. All right, let's do a harder one. They do get a little more difficult if you're using the table. Letter B. What proportion of students is older than 23.7? Okay, so older than 23.7. So here we go. 23.7. So 24.5. 23.7 would be here, and I want older. Okay, so 23.7. So you should be able to identify the fact that my z-score is going to be negative because it's to the left of the mean. So let's start out with just our z-score is equal to 23.7 minus 24.5 all over 2.5 negative 0.32. Okay, so the z-table is a little bit more confusing than the calculator, so I do want to go over that. The z-table, remember, only gives you area, and I'm going to do like this bright highlighter green. That z-score, which is right here, negative, right at this line, the calculator is actually going to give you, sorry, not the calculator. The z-scores always give you less than, but here's the interesting thing. You're not going to find a z-table with negative values. You're actually going to be able to find the z-score of positive 0.32 on a table, but not negative 0.32. So the question is, how do you relate those two? So let me undo pretty much my shading just to show you what you're going to be looking at. Sorry. All right, so if I use the z-score, let's use black. So the z-score that I'm going to use is positive 0.32 because the table does not have negative 0.32. I am going to shade what the z-score would give me. So it would be symmetric, remember? Symmetric. Actually, let me use yellow. It'll be a little more visible. So symmetrically, here is the area that it's going to give me, the yellow. So what I wanted was this purple side. What it's going to give me is that yellow side. What you will notice, they're exactly the same. So even though my z-score is a negative, because I need greater than that z-score, I'm actually going to be able to just use that positive z-score. So going back to this guy, 0.3, and then 2, 0.32, 0.6255. So equals 0.6255. And then calculator, much easier. We are going to do second bars. Number 2, CDF, remember. So this time my lower is 23.7. And then my upper is some value 5 standard deviations away. I'll just pick 100. And my standard deviation, my mean, all the same. So enter till I get to here. Press enter. And 0.6255, which is the same value. So your calculator is actually doing an integral. That's how it's doing this. All right. Oopsie, I did not mean to X out my calculator. That's not what I meant to do. All right. Next, part C, between. So I'm going to actually erase what's on the screen here so we can do letter C. What percentage of students is between 22 and 28? So I'm just going to start with my picture. Mean of 24.5. 22 would be less than it, somewhere over here. And then 28 would be somewhere over here. And they want this shading. So I'm going to make the assumption that if you're using your calculator, you would be able to do that problem very easily. Minimum value 22, maximum value 28. So the harder one would be doing this without. So if they were to give you a z-table, meaning this is a non-calculator problem, that is definitely a little bit harder. So what I want to show you is underneath here, if I was to use my z-table and try to use 28, it's going to give me all of this area. All of it. So this obviously takes a little bit more thought. Now 22 is interesting. 22 is negative. That's 28. So 22 is negative, and it won't allow me to use negative z-scores in the table. So symmetrically, 22 on the left, we're going to end up having to use a z-score that's positive. So let me actually find the z-scores first. Start out with x. So I'm going to do 22 first. So 22 minus 24.5 all over 2.5. And that is a z-score of hopefully -1. Sometimes I look at the board and I feel like I can't do basic math anymore. All right, 28. So 28 minus 24.5 all over 2.5, which equals a z-score of 1.4. All right, so the 28, this z-score is 1.4. I'm going to use my table, get down to 1.4, 0.0, so 0.9192. 0.9192. So that would be that whole pink area right here. So now I'm turning it purple. All of it. Okay. The problem is my z-score of -1 will not show up on the table because of the fact that they only give you the positive values. So I'm going to actually use +1, which is 0.8413. So, let's do 0.8413, z-score equals +1. All right, so what does that give me? Even though 22 is on the left here, if I knew the area that was here, I could take the z-score of 1.4 and its probability, which was 0.9192, and subtract away this little tail. Okay? But the calculator doesn't give me that tail. It actually gives me, sorry, not the calculator, the table gives me the positive 1 z-score instead of the negative 1 z-score. So it's a little bit confusing. I'm running out of space. So this area then is this big old red area. So what I'm hoping you understand is if I do 1 minus 0.8413, I will end up with 0.1587. That is this area right here, 0.1587. Right? Remember, the area underneath the whole entire normal distribution is 1. The z-score of positive 1 gave us this area number, which is in red right here. And so if I subtract it, I'm left with that tail. Well, that tail happens to be the same as this little guy right here. So my final answer, convoluted as it is, would be that large area right here, 0.9192, take away the tail, which was 0.1587. Which then becomes 0.9. Oh, sorry guys. I don't want to make a little mistake by doing all this in my head, so just make sure. All right, 0.7605, 0.7605. So hopefully if I didn't make any mistakes, if you use your calculator, you get that same exact value. Now, letter D is just going to be within 1 standard deviation. Those are your empirical data. So I know that this board is a little bit messy. It's messier than I would usually like, but I want to just make sure you understand that z-tables, will only give you values where z is greater than or equal to 0. 0, you know the z-score is 0. It also then, when you're normally distributed, only gives you z-values on this side. And when it gives you a z-value, it gives you the area always to the left in that table. So easy questions are anytime we do a probability where x is less than or equal to some z-value that's bigger than 0. Those are the easiest problems. The problem I just did is one of the more complicated ones, where here's your mean, and I give you a z-value on this side and a z-value cut on this side. Those are actually the hardest. So please try the problems. I do want you to use your calculator to verify for a few, because you should have no problem using your calculator. Any of the values that they're giving you easy values to figure out the z-scores of, I do want you to use the table. And for every single question, I should still see a z-score and a sketch, because that is really two pieces of information they may actually just ask questions on. Okay? Sorry if this was a little bit confusing. I can definitely review with you guys tomorrow in class.